Okay, now you start sharing. Okay. So today we will learn the principles of item analysis. Okay, Mona Lisa, when you are talking about the psychometrics, that means you have to study the items. So in the questionnaire, you will find the items, and each item is the representative of the behavior that is measured by the construct of the questionnaire. For example, the questionnaire that is measuring depression, each item should represent some behavioral pattern of the depressive people or the people suffering from major depression. Now, when we analyze the item, there are different properties are there. One property is item difficulty. Here, item difficulty, this is usually we follow in case of the power test. Okay. For example, academic achievement test. That is the power test. That is your knowledge. Intelligence. That is the power test. Particularly in case of the academic achievement test, initially you have to study the item difficulty of the test. That is proportion of test takers who answered the item correctly. Range is from 0 to 1, where higher values indicate easier items. Typically, items with a difficulty between 0.3 and 0.7 are considered to have an optimal balance for most assessment. 0.7 means 70% of the total test takers, they answered correctly. That means these items are very easy. And if it is 0.3, that means 30% of the total respondents can write the answer correctly. That indicates this item is relatively difficult to the respondents. Okay. This is the item difficulty. Next. Oh, this is the picture. It represents the item characteristics curve. Now here you will find that is the item difficulty for the question that belongs to this ICT. Someone with an IQ of 118. 118 has a 50% chance of giving the answer, and the average IQ is 100. So this question is answered correctly by less than half of the people. Someone with an IQ of 90 only has around 20% chance of getting the right answer to the question. This question that belongs to this ICC is much more difficult than the question that belongs to the other ICC. Okay, so this is the item characteristics curve, and you will find that is the item, the probability of correct answer. So when individual score is high, so they are more probability for writing the correct answer. Okay. For example, this is the card. Whether my arrow is visible? Hello.
Yes, sir.
So here it is the 50% probability. Then the score is 118. That means students who are very good, they are performing well, but the students who are very poor, for example, some students get the score 90. Therefore, their probability of writing the correct answer is 20. Okay. That means students perform better and their probability of correct answer is also good. This is called the item characteristics curve. Next. This is another item characteristics curve. Here you will find that is the score is 90, but the performance is better. Okay. That means whether this item in the first ICC, someone with an IQ of 90 has a 50% chance of giving the correct answer, and the average IQ is 100. So the question is answered correctly by more than half of the people. Okay. Next. So this indicates that is which item is better and which item is not suitable. Next point is item discrimination index. After item difficulty, item discrimination. The ability of an item to differentiate between high and low performers on the test. often measured by the point biserial correlation between item score and total test score, or by the difference in item performance between the top and bottom quartiles of test takers. So in this manner, you can study. That is either by the point biserial or by the difference in item performance. Ideal value, positive values close to 1 indicate group discrimination, with values above 0.3 being desirable. So that indicates item discrimination. For example, you want to study the depression level. So that is the highly depressed people and relatively less depressed people, whether these two groups can be significantly different with respect to the means or not. Okay, that thing you can do. Or you can do the point biserial correlation between item scores and the total test score. So x-axis will be the dichotomous and y-axis that will be the non-dichotomous. In this manner, you can assess the item discrimination. So if the correlation is very high, it is written positive values close to 1 indicate good discrimination, with values above 0.3 being desirable. My suggestion, you should concentrate on the item total correlation by using the point biserial or by testing the item mean-wise difference between the top and bottom quartiles of the test taker. That is better. Hara, this is ideal value. What you have written, that is not clear.
Sir, sir, it was
Because
from
if the correlation is very high,
yes,
so you have written positive values close to 1.
yes, sir. Sir, it was from Google Classroom. Okay, sir, I'll correct it.
You will
I will
check
correct.
with values above 0.3 being desirable, you have written. And whatever the card you are showing, that is not similar. Two things are not similar. Okay, go to the next. Distractor analysis. Distractor analysis is very important, particularly when you are designing multiple choice items. For example, you have a question and 4 options are there. So if you follow the equal probability, that means equal probability will be the 25%. Okay. And if you find that is maybe 10% people they are able to answer correctly. That means other people are distracted by the item. So distractors should be plausible to ensure that they attract less knowledgeable test taker. Ideally, each distractor should be chosen by some percentage of test takers to confirm that they are functioning as intended. Non-functioning test takers chosen by very few or no test takers may need revision. So when you make the power test using the multiple choice item, usually we are following, in case of the psychometric test for selection purpose, we are using the power test. So multiple choice items are there, and there will be the equal probability. So if you find that is the equal probability is not followed by the result, then you can think about the distractor. Next. This is already done. Graphical representation of the probability of a correct response to an item across different levels of the underlying trait being measured. This is called the item characteristics curve. So here you can find out the item difficulty, 50% chance. When the score is 120, then 50% chance is the correct type. Another one is this is the item difficulty. And next one is the item discrimination. So again, the score is high, and there the students are able to discriminate the good item. Good item means high chance of giving the correct answer. So that is possible. That is by the more than 50% of the people. Now this is the item characteristics curve. It follows S pattern. It is used in item response theory to assess how well an item performs across different ability levels. So this x-axis indicates the ability levels. If the ability levels low and the percentage of correct answer is low, and the ability level high, percentage of correct answer is high, that item characteristics is the good representation. Okay. So this is the rash model. There are different item response theory অনুযায়ী. There are different models. That is the first parameter model. it considers only the item difficulty. So here again, you will find the theta that indicates basically ability level. Okay. And PU is the probability level. Now here you can find out that is the score is above 0, then the probability level for the correct answer is 50%. So this is the first item parameter. One parameter model. Okay. Next. Now the two parameter model, it considers both item difficulty and item discrimination. Now you always follow the probability level and the theta level. Okay. When the theta level is high and students perform better, okay, that means item discrimination and item difficulty both are good. For example, here you can find out the item 3. Item 3 when it crosses 0, then it improves better. Item 3. But item 1, it is less difficult because in item 1, you will find that is the score is below the 0 and the students perform 50%. That means the ability level is low, but the student is performing well. That means this item is very easy. This item is not the good item. Item 3 is the better item. Item 2 also better than the item 1. Next. It is a 3-parameter model. It includes the guessing parameter plus item difficulty and item discrimination. So 3-parameter models that can be assessed correctly. So figure 3 has item discrimination A equal to 2.5 and item difficulty B equal to -1. When the probability of getting the item response, item correct is 1 plus 0.25 divided by 2 equal to 0.655 because C equal to 0.25. That is the probability of the lowest ability students getting this item correct, 25%. Okay, so that is for the item 1. You will find that is the score is high. So these students, they are performing well when the score is low. So when you do this type of item curve analysis, then you can find out these three things. That is the item difficulty, item discrimination, and the guessing parameter. All those things are available. But keep in mind that we cannot assess these three using the SPSS. For that reason, we have to purchase another SPSS module through which we can study these item parameters. Our available SPSS model is not sufficient, or you can study the item parameters using RStudio. Next. Now we are coming to the reliability analysis. Reliability means consistency. So two types of consistency are there. One consistency is the time consistency. Another consistency is the internal consistency. Time consistency means test, retest, reliability. And internal consistency, that means the items of the questionnaire, they are correlated with each other. When they are correlated with each other, that means we can do the Cronbach's alpha. And if we find that is the Cronbach's alpha is above 0.8, then we can tell that is the items are good with respect to the internal consistency. And for that reason, you have to study the item analysis and item total correlation. But Farah, you have to show the test retest reliability, not the item total correlation. Item total correlation, that is for the internal consistency. You have not shown the test retest reliability.
Okay, sir, there is a paper. So there's your paper, sir. Can I suggest that paper for to students? Your paper.
Which paper?
Sir, it is, I think, on for sir, that the paper that you have suggested to Teja and Naresh Babu.
Oh, acha. Yes, that you can share now. Otherwise, students cannot understand.
Okay, sir, just give me a second.
Yeah, this is the dendrogram. Here you can find out that is the dendrogram indicates what happened. Related to the knowledge motivation. You will find that is the items they are close to each other. Okay. Following the test and retest item. For example, here you will find the Kn1 that is close to the Kn2. Similarly, Kn K2 that is close to the KNU2. Okay, that means the test data and the retest data, test item and the retest item, they are very close to each other. Here again you will find that is the table 3 between items homogeneity. APN and APP2 Euclidean distance is 2.65. Kn1 and Kn2 Euclidean distance is 2.45. That means they are very close to each other. Okay, so if you find that is the item wise, test item and the retest item, they are very close to each other, then you can suggest that your questionnaire has good test and retest reliability. Okay. This is all about the applied psychometrics with respect to the item analysis as well as the reliability. And there are some items you will find that is their dendrogram does not follow the similarity. They are highly classified. Okay, if they are very much classified, that means the test and retest reliability that is relatively low because they are classified into different groups. So what is the next page? Achievement motivation after that. Harm avoidance motivation is there. Need for affiliation and need for a dendrogram is not there.
Yes, sir. Dendrogram I cannot see. The dendrogram is not there.
Okay, you go to the recognition motivation. Recognition motivation is the externally motivated, and you will find that is these items, they are not clustered together properly. For example, first item is RC1 and RC22. They are close to each other. So it should be the RC1 and RC2. They will be close to each other, but RC2 is close to the RCP2. Okay, that means they are not following the systematic relationship. These are the extrinsic motivation factors. So the test retest reliability, that is also very poor with respect to the extrinsic motivation. But if it is intrinsic motivation, then the test retest reliability is high. So that is the interesting observation of this study. Okay. So this is the applied psychometrics with respect to the reliability and item analysis. For your purpose, you can do the item total correlation. You can test the item-wise mean difference. Even you can do the point by serial. But the rash model and other things that may not be possible in the available SPSS. For that reason, we have to purchase another module. Okay, Kavita.
Yes, sir.
Mona Lisa, is it clear now?
Yes, sir.
Okay. So Farah, now we can close.
Yes, sir, we can close the session. Thank you, sir.
Thank you, sir.
Thank you. Welcome.
Thank you, sir.